The universe is often thought of as a vast, chaotic expanse, a random scattering of stars and planets adrift in the void. But what if we've been looking at it all wrong? What if, instead of chaos, the cosmos is a meticulously crafted masterpiece, a grand work of art painted across the canvas of existence? Every star, every planet, every swirling galaxy could be a deliberate brushstroke, contributing to a larger, more harmonious picture. This is the idea at the heart of decoding the celestial blueprint. It's an invitation to see the universe not as a collection of isolated phenomena, but as an interconnected system, a symphony of elements working together in ways we're only beginning to understand. What if the universe isn't just something we observe, but something we can interpret like a painting or a piece of music? What if the mysteries of the cosmos aren't just scientific puzzles, but clues to a deeper, more profound truth? In this video, we'll explore the idea of the universe as a grand work of art, diving into the science of cosmic design, the role of human perception, and the awe-inspiring implications of seeing the cosmos as a masterpiece. Get ready to rethink everything you thought you knew about the stars, and maybe even your place among them. From the swirling arms of spiral galaxies to the delicate dance of planets around their stars, the universe reveals patterns so intricate, so deliberate, that they seem to echo the work of an artist rather than the randomness of chaos. Think about it. When we look at a painting, we don't just see random splashes of color. We see intention, balance, and meaning. What if the cosmos is no different? Ancient civilizations certainly thought so. The Greeks imagined the night sky as a tapestry woven by the gods, while the Mayans saw celestial bodies as pieces of a divine puzzle, each with its own sacred role. These cultures didn't just observe the stars, they interpreted them, finding stories, symbols, and deeper truths in the heavens above. Fast forward to today, and modern science offers a fascinating twist on this ancient idea. Take fractal geometry, for example, a mathematical concept that reveals repeating patterns at every scale, from the branching of trees to the structure of galaxies. Or consider the golden ratio, a proportion so perfectly balanced that it appears in everything from seashells to the orbits of planets. Even the Fibonacci sequence, a series of numbers found in nature's most elegant designs, shows up in the spirals of galaxies, as if the universe itself is following a blueprint. These aren't just coincidences, they're clues pointing to an underlying order that feels almost artistic. So, what does this mean for us? If the universe is a grand work of art, then every star, every planet, every swirling nebula is part of a larger composition, one that we're only beginning to understand. But here's the real question. If the cosmos is a masterpiece, who or what is the artist? And what might this tell us about our place in the grand design? As we peel back the layers of this cosmic mystery, we'll uncover even deeper connections, ones that challenge our understanding of reality itself. The canvas of the universe is vast, and the story it tells is far from finished. For thousands of years, humans have looked up at the night sky and seen more than just stars, they've seen stories. Across cultures and continents, the heavens have served as a canvas for myth, meaning, and mystery. The constellations we recognize today, Orion, Ursa Major, the Southern Cross, are more than just random groupings of stars. They're symbols etched into the sky by the imaginations of our ancestors. The Greeks saw heroes and monsters, while the indigenous Australians saw emus and hunters. These patterns weren't just decorative, they were maps, calendars, and even moral guides. The zodiac, for example, isn't just a tool for astrology. It's a system that reflects humanity's desire to find order in the cosmos. But what if these patterns aren't just human inventions? What if they're part of a deeper, universal language waiting to be decoded? Consider the ancient Egyptians who aligned their pyramids with astonishing precision to match the stars of Orion's belt. For them, the heavens weren't just a backdrop, they were a blueprint, a sacred guide to building a connection between Earth and the cosmos. Or take the Polynesian navigators who sailed vast oceans without modern instruments, relying entirely on star maps etched into their collective memory. To them, the stars weren't just points of light. They were a living, breathing guide, a celestial roadmap that spoke a language of direction and purpose. These cultures didn't just observe the stars, they listened to them, interpreting their patterns as messages from something greater. But here's where it gets fascinating. What if these patterns are more than cultural symbols? What if they're part of a universal language, one that transcends human interpretation? Modern science hints at this possibility. The mathematical precision of planetary orbits, the repeating fractal patterns in galaxies, even the way light bends around massive objects, all of these suggest an underlying order, a kind of cosmic grammar. Could it be that the constellations and zodiac signs are not just human constructs, but fragments of a larger code? A code that, if we could decipher it, might reveal the universe's deepest secrets. This idea isn't just poetic, it's profound. If the stars are indeed part of a universal language, then every constellation, every planetary alignment, every celestial event could be a word or phrase in a cosmic conversation. A conversation that's been going on since the dawn of time, waiting for us to tune in. And if that's true, then understanding this language might be the key to unlocking the universe's blueprint, a blueprint that could explain everything from the birth of stars to the nature of reality itself. So the next time you look up at the night sky, don't just see the stars, listen to them. What might they be trying to tell us? Now, let's zoom way in to one of the most mesmerizing patterns in the cosmos, fractals. These intricate, self-repeating shapes are everywhere in nature, from the branching veins of a leaf to the jagged coastline of a continent, but they don't stop at Earth's surface. Fractals appear in the very fabric of the universe itself, weaving their way through galaxies, nebulae, and even the distribution of matter on the largest scales. The idea is simple yet profound, patterns that repeat themselves no matter how far you zoom in or out. It's as if the universe is echoing its own design, whispering the same message across every scale of existence. Take the Mandelbrot set, for example, a mathematical marvel that reveals an infinite cascade of intricate shapes, each one a smaller version of the whole. When you look at it, you might notice something familiar. The swirling arms of a spiral galaxy, the delicate tendrils of a cosmic nebula, or even the branching structure of a tree. It's uncanny how much this mathematical construct mirrors the natural world and the cosmos beyond. But what does this mean? Could it be that the universe operates on a kind of fractal blueprint, where small-scale patterns reflect larger ones in an endless dance of repetition? The evidence is hard to ignore. Look at the way galaxies cluster together, forming vast webs of matter that stretch across the universe. These clusters aren't random, they follow a fractal-like structure, with smaller groups of galaxies nested within larger ones, repeating the same pattern over and over. Even the distribution of stars within a galaxy echoes this principle, with dense clusters giving way to sparse regions in a rhythm that feels almost orchestrated. And then there are nebulae, those glowing clouds of gas and dust that birth new stars. Their shapes, too, are fractal in nature, with wisps and tendrils branching out in a way that feels both chaotic and deeply intentional. But here's the real kicker. If fractals are such a universal feature, from the tiniest snowflake to the largest galaxy, does that mean they're just a happy accident? Or could they be evidence of something deeper, a kind of cosmic rulebook that governs how things form and grow? Some scientists argue that fractals are a natural outcome of the laws of physics, a side effect of how energy and matter interact. Others wonder if there's more to it. if these repeating patterns hint at a deliberate design, a kind of artistic signature woven into the fabric of reality. So, as we marvel at the fractal beauty of the cosmos, we're left with a tantalizing question. Is this infinite repetition just a mathematical quirk, or is it a clue to something far grander? If the universe truly follows a fractal blueprint, what might that tell us about its origins and our place within it? The answers may lie hidden in the stars, waiting for us to decode their secrets. Imagine a number so perfect, so harmonious, that it appears in everything from the petals of a flower to the spirals of galaxies. This number, approximately 1.618, is known as the Golden Ratio, and it's been celebrated for centuries as nature's ultimate expression of balance and beauty. Artists like Leonardo da Vinci and architects of the Parthenon used it to create works that feel instinctively pleasing to the eye. But the Golden Ratio isn't just a human invention, it's woven into the very fabric of the universe. From the curves of seashells to the branching of trees, this proportion seems to be a universal signature, a mathematical constant that ties the natural world together. And when we look to the cosmos, we find that same signature written in the stars. Take the spiral arms of galaxies, for instance. These vast, swirling structures aren't just random formations, they follow a pattern that mirrors the Golden Ratio. The way they curve outward, growing wider as they spiral, matches the same proportions found in a nautilus shell or a sunflower's seed arrangement. Even the distances between planets in our solar system, when plotted out, reveal ratios that align closely with the golden mean. It's as if the cosmos has a built-in aesthetic, a preference for this particular balance. But why does this ratio feel so pleasing? Some scientists believe it's tied to the way our brains process information. The Golden Ratio creates a sense of harmony and proportion that our minds find inherently satisfying, a kind of visual music that resonates with us on a deep, almost primal level. Others suggest it's not just about perception, it's about efficiency. The Golden Ratio allows structures to grow and expand in a way that maximizes space and energy, making it an ideal blueprint for both nature and the universe. What's truly fascinating, though, is the possibility that this ratio isn't just a mathematical curiosity. It might be a clue to the universe's artistic intent. If the Golden Ratio appears so consistently across scales, from the microscopic to the cosmic, could it be evidence of a deeper design? A kind of universal language of beauty that transcends human understanding. When we see it reflected in the spiral of a galaxy or the orbit of a planet, it's hard not to wonder if the cosmos itself is an artist, using this ratio as its brushstroke to paint a masterpiece across the void. So, the next time you gaze at a spiral galaxy or marvel at the symmetry of a sunflower, remember this: you're not just looking at random patterns, you're witnessing the Golden Ratio in action, a mathematical constant that connects the smallest details of life to the grandest structures in the universe. And if that's the case, then perhaps beauty isn't just in the eye of the beholder, it's written into the stars themselves. But what happens when we zoom out and consider the universe on the grandest scales? Here, we find a different kind of symmetry, one that governs the very forces shaping existence. From the delicate balance of gravity pulling matter together to the uniformity of the cosmic microwave background radiation, the cosmos seems to operate on principles of balance and harmony. Think of it as the universe's way of maintaining equilibrium, a cosmic dance where every force has its counterforce. This symmetry isn't just a scientific curiosity, it's a hallmark of both art and science, a shared language that speaks to the elegance of the cosmos. Take the humble snowflake, for example. Each one is a masterpiece of symmetry, with its intricate, branching patterns radiating outward in perfect balance. No two snowflakes are exactly alike, yet they all share this underlying order. Now shift your gaze to the stars, star systems too, often display a remarkable symmetry, with planets orbiting in predictable, harmonious patterns. Even the spiral arms of galaxies follow a rhythmic, almost musical symmetry, as if the universe itself is a composer, arranging matter into a grand symphony. But symmetry isn't just about beauty, it's about function. Consider the forces that hold the universe together. Gravity, electromagnetism, the strong and weak nuclear forces. They all operate in a delicate balance, each one counteracting or complementing the others. Without this symmetry, the universe as we know it wouldn't exist. Stars wouldn't form, planets wouldn't orbit, and life itself would be impossible. It's as if the cosmos has a built-in rulebook, one that ensures everything stays in perfect alignment. Yet for all its elegance, symmetry alone doesn't tell the whole story. Enter asymmetry, the subtle imperfections that add depth and complexity to the universe. Think of a spiral galaxy, its arms slightly uneven, or a nebula, its swirling clouds chaotic yet breathtakingly beautiful. These asymmetries aren't flaws, they're essential ingredients in the cosmic recipe. Without them, the universe would be static, uniform, and frankly, boring. It's the interplay between symmetry and asymmetry that creates the richness and diversity we see around us, from the tiniest atom to the largest galaxy. So, what does this mean for our understanding of the universe? If symmetry represents the universe's underlying order, then asymmetry is its creative spark, the element that transforms simplicity into complexity. Together, they form a dynamic partnership, one that shapes everything from the birth of stars to the emergence of life. And perhaps, just perhaps, this balance between symmetry and asymmetry is the ultimate expression of the cosmos as a work of art, a masterpiece that's both perfectly balanced and beautifully imperfect. As we continue to explore the celestial blueprint, we'll uncover even more ways in which the universe reveals its artistic nature. From the symmetry of forces to the asymmetry of structures, each discovery brings us closer to understanding the grand design and our place within it. The cosmos isn't just a collection of random events, it's a carefully crafted composition, one that invites us to look deeper, think bigger, and marvel at the beauty of it all. At first glance, chaos might seem like the antithesis of art, a messy, disruptive force that shatters harmony. But what if chaos is not the enemy of beauty, but its co-creator? Throughout the cosmos, we find moments of unpredictability that seem to defy order, yet these very moments often give rise to the most breathtaking phenomena. Supernova, for instance, are cosmic explosions of unimaginable power, scattering stardust across the void. While they may appear destructive, they're also the universe's way of recycling matter, seeding the cosmos with the building blocks of new stars, planets, and even life itself. In this sense, chaos isn't just a random occurrence, it's a vital part of the cosmic process, a kind of creative destruction that fuels the universe's ongoing evolution. Then there are black holes, those enigmatic regions where gravity is so intense that not even light can escape. On the surface, they seem like the ultimate symbol of chaos, a place where the rules of physics break down. But even here, order emerges from the disorder. Black holes aren't just cosmic vacuum cleaners, they're also engines of creation. The immense energy they release can shape entire galaxies, sculpting their structures and influencing the birth of stars. In a way, black holes are like the universe's wildcard artists, adding dramatic, unpredictable flourishes to the cosmic masterpiece. And let's not forget cosmic collisions, those spectacular encounters where galaxies crash into one another, their stars flung into new orbits, their gas clouds compressed into bursts of star formation. These events might seem chaotic, but they're also transformative. Out of the chaos, new patterns emerge, new symmetries are born, and the universe evolves in ways that are both dynamic and deeply beautiful. It's as if the cosmos is an artist who thrives on spontaneity, using chaos as a tool to push the boundaries of its own creativity. This interplay between chaos and order isn't just a feature of the universe, it's fundamental to its very nature. Without chaos, the universe would be static, unchanging, and devoid of the richness we see around us. Chaos introduces unpredictability, yes, but it also creates opportunities for growth, innovation, and transformation. It's the reason why no two galaxies, no two stars, and no two planets are exactly alike. It's what makes the universe a living, breathing work of art, constantly evolving and surprising us with its complexity. So, when we look at the cosmos, we shouldn't see chaos as a flaw or a disruption. Instead, we should see it as an essential ingredient in the universe's artistic process, a force that, when paired with order, creates a dynamic tension that's as beautiful as it is profound. Chaos and order aren't opposites, they're partners working together to shape the grand design of existence. And in that partnership, we find the true essence of the universe's artistry, an artistry that's both perfectly planned and beautifully unpredictable. Human perception is a powerful lens through which we interpret the universe, a lens that often blurs the line between reality and imagination. Our brains are hardwired to seek patterns, to find meaning in the chaos, and to impose order on the random. It's a survival mechanism, one that has allowed us to navigate the world for thousands of years. But it's also what makes us uniquely capable of seeing the universe not just as a collection of objects, but as a work of art. Take the Rorschach test, for example. Those ink blots, random and abstract, become something entirely different when viewed through the human mind, a butterfly, a face, or even a galaxy. The same principle applies to the stars. When we look up at the night sky, we don't just see scattered points of light. We see constellations, stories, and symbols. It's as if our brains are painting over the cosmos, filling in the gaps with meaning. This tendency to find patterns where none exist is known as pareidolia, and it's everywhere in our lives. We see faces in clouds, animals in rock formations, and shapes in the stars. The Big Dipper, for instance, isn't a real structure in the sky. It's a pattern we've imposed on a random arrangement of stars. But does that make it any less real? For thousands of years, these patterns have guided explorers, inspired poets, and shaped cultures. They've become a part of how we understand the universe, turning the cosmos into a canvas for our collective imagination. Yet, this raises a fascinating question. Is the universe's artistry something inherent, or is it a product of how we perceive it? On one hand, we have the undeniable patterns of nature, the golden ratio in galaxies, the fractal geometry of nebulae, the symmetry of planetary orbits. These are objective, measurable phenomena that suggest an underlying order. On the other hand, there's the way our brains interpret these patterns, adding layers of meaning and beauty that may not exist outside of our perception. It's a delicate balance between what's real and what we make real. Consider this: when we look at a painting, we don't just see the brushstrokes, we see the emotion, the story, the intent behind them. The same could be said of the universe. The patterns we find in the stars, the shapes we see in the clouds, the symmetry we admire in galaxies, they're all part of a dialogue between the cosmos and our mind. The universe provides the raw materials, and we, as observers, bring them to life. So, is the universe a masterpiece because it's inherently beautiful, or because we've chosen to see it that way? Perhaps the answer lies somewhere in between. The cosmos offers us patterns and symmetries, but it's our perception that transforms them into art. In this way, the universe isn't just a work of art, it's a collaboration, a partnership between the cosmos and the human mind. And as we continue to explore and interpret the stars, we're not just decoding the celestial blueprint, we're adding our own brushstrokes to the canvas. If the universe is a grand work of art, then the multiverse theory invites us to imagine an entire gallery, a cosmic exhibition filled with infinite masterpieces, each one unique in its design. This idea, rooted in some of the most cutting-edge theories in physics, suggests that our universe might not be alone. Instead, it could be just one of countless others, each with its own set of physical laws, dimensions, and histories. Picture it, a vast, unimaginable collection of universes, each one a canvas painted with different strokes of matter, energy, and time. Some might be bursting with color and life, while others could be stark and barren, their landscapes shaped by forces we can barely comprehend. The multiverse theory doesn't just expand our understanding of existence, it transforms the way we think about the universe as art. If there are infinite universes, then there are infinite possibilities for beauty, complexity, and creativity. One universe might be a symphony of swirling galaxies, another a minimalist arrangement of black holes and empty space. Each one could be a unique expression of the same underlying principles, a variation on a theme written by the laws of physics. It's as if the cosmos is an artist experimenting with endless styles, colors, and textures, creating a gallery so vast that no one could ever see it all. But what does this mean for the idea of a singular celestial blueprint? If our universe is just one of many, then the patterns we see, the golden ratio, fractals, symmetry, might not be universal truths, but simply the aesthetic of our particular universe. In another universe, the rules might be entirely different, with no golden ratio, no spiraling galaxies, no familiar constellations. The very idea of beauty could be redefined, shaped by entirely new principles of physics and geometry. This challenges us to rethink not just our place in the cosmos, but the nature of art itself. Is beauty universal, or is it a product of the specific conditions we happen to live in? Some theorists even suggest that the multiverse could be a kind of cosmic laboratory, where every possible version of reality is tested and explored. In this view, our universe isn't special or unique. It's just one experiment among an infinite number of others, and yet it's the only one we know, the only one we can experience. That makes it precious, a masterpiece in its own right, even if it's just one of countless others. The multiverse theory also raises profound questions about creativity and intention. If there are infinite universes, does that mean every possible design has been realized somewhere? Or are there still undiscovered possibilities waiting to be explored? And if the cosmos is an artist, does it have a vision, a purpose, or is it simply creating at random, driven by the laws of probability? These questions push us to the edge of what we can know, challenging us to imagine a reality far beyond our own. As we ponder the multiverse, we're reminded that the universe, or universes, are far more complex, more mysterious, and more beautiful than we can ever fully grasp. The multiverse theory doesn't diminish the artistry of our universe. It expands it, inviting us to see our home as part of an infinite tapestry, woven with threads of possibility. And in that tapestry, we find not just answers, but endless questions that keep us looking up, wondering, and dreaming. Now, let's turn our attention to two of the most elusive and enigmatic forces in the cosmos, dark matter and dark energy. Together, they make up about 95% of the universe, yet they remain invisible to our eyes and instruments. Think of them as the invisible brushstrokes on the cosmic canvas, unseen, yet undeniably shaping the grand design of existence. Without them, the universe as we know it would look entirely different. But what exactly are they, and how do they influence the masterpiece we call the cosmos? Dark matter is the mysterious substance that doesn't emit, absorb, or reflect light, making it completely invisible, yet its presence is felt everywhere. It's the glue that holds galaxies together, providing the gravitational pull needed to keep stars from flying apart. Without dark matter, galaxies would spin themselves into chaos, their stars scattering into the void. It's like the unseen scaffolding behind a painting, holding the structure together while remaining hidden from view. Scientists have spent decades searching for dark matter, using everything from particle colliders to underground detectors, but it continues to elude us. What we do know is that it's out there, shaping the universe in ways we're only beginning to understand. Then there's dark energy, an even more perplexing force. Unlike dark matter, which pulls things together, dark energy pushes them apart. It's the reason the universe is expanding at an accelerating rate, stretching the fabric of space-time itself. Imagine an artist adding more and more canvas to a painting, ensuring that every brushstroke has room to breathe. Dark energy is that expansive force, driving the universe to grow larger and faster with each passing moment. But what causes it? Is it a property of space itself or something entirely different? These are questions that keep scientists up at night, searching for answers in the faint echoes of the Big Bang and the vast emptiness between galaxies. Together, dark matter and dark energy form the invisible framework of the universe, shaping its structure and guiding its evolution. They're like the unseen hand of the artist, working behind the scenes to create a masterpiece we can only partially comprehend. And while we can't see them directly, their influence is everywhere in the way galaxies cluster together, in the stretching of cosmic voids, and in the very fate of the universe itself. So, what does this mean for the cosmic blueprint? If the universe is a work of art, then dark matter and dark energy are the hidden techniques, the quiet forces that bring balance and movement to the composition. They remind us that beauty isn't always visible, that sometimes the most profound elements are the ones we can't see. As we continue to explore these mysteries, we're not just decoding the universe, we're uncovering the invisible threads that weave it together. And in doing so, we're learning that the cosmos is far more intricate, more mysterious, and more beautiful than we ever imagined. The quest to understand dark matter and dark energy is far from over. It's a journey that takes us to the very edge of what we know, challenging us to see the universe in new ways. And as we peel back the layers of this cosmic mystery, we're reminded that the universe isn't just a static painting. It's a dynamic, evolving masterpiece, one that invites us to keep looking, keep questioning, and keep marveling at its infinite complexity. Imagine standing before a blank canvas, brush in hand, ready to make the first stroke. That moment of creation where nothing becomes something is both exhilarating and mysterious. Now picture the universe as that canvas and the Big Bang as the first stroke of the cosmic brush. In an instant, everything we know, time, space, matter, and energy burst into existence. This wasn't just the beginning of the universe, it was the moment the cosmic masterpiece began to take shape. The Big Bang wasn't an explosion in the traditional sense. Instead, think of it as the rapid expansion of space itself, a sudden unfurling of potential. In those first moments, the universe was unimaginably hot and dense, a seething soup of energy. But as it expanded and cooled, the first particles began to form: quarks, electrons, and photons, the building blocks of everything we see today. Over time, these particles combined to create the simplest atoms, hydrogen and helium. It's like the artist laying down the first layers of color, setting the foundation for the intricate details to come. This early universe was far from static. Tiny fluctuations in density, random ripples in the cosmic fabric began to grow, thanks to gravity. These ripples became the seeds of galaxies, clusters, and superclusters, the grand structures that define the cosmos today. It's as if the universe was sketching its own outline, using gravity as its pencil. And just as a painting evolves from broad strokes to fine details, the universe grew more complex over billions of years, giving rise to stars, planets, and eventually life. But how do we know all this? One of the most remarkable pieces of evidence comes from the cosmic microwave background, or CMB. This faint glow, detected in every direction of the sky, is the afterglow of the Big Bang itself. It's like the artist's signature, a faint but unmistakable mark left behind by the universe's creation. The CMB isn't just a relic of the past, it's a treasure trove of information. By studying its subtle variations, scientists have been able to map the early universe, revealing details about its age, composition, and even its fate. The Big Bang didn't just set the stage for the universe's evolution, it established the rules of the game, the laws of physics, the balance of forces, the distribution of matter. All of these were determined in those first moments. And yet, the story doesn't end there. The echoes of the Big Bang continue to shape the cosmos, influencing everything from the formation of galaxies to the movement of stars. It's a reminder that the universe isn't just a static painting, it's a dynamic, ever-evolving work of art. So, the next time you look up at the night sky, remember this: you're not just seeing stars and galaxies. You're witnessing the legacy of the Big Bang, the first stroke of a cosmic brush that set the universe in motion. And as we continue to explore and understand these beginnings, we're not just decoding the universe's history, we're uncovering the artistry behind its creation. The Big Bang wasn't just a moment in time, it was the spark that ignited a masterpiece, one that's still unfolding before our eyes. When we think of art, we often imagine something static, a painting hanging on a wall or a sculpture frozen in time. But the universe is a different kind of masterpiece, one that's alive with motion and change. Time is the dimension that brings this cosmic canvas to life, transforming it from a static image into a dynamic, ever-evolving creation. Without time, the universe would be like a paused movie, full of potential but devoid of movement. It's time that allows stars to be born, galaxies to collide, and life to emerge. In this sense, time isn't just a backdrop, it's an active participant in the universe's artistic process, shaping its story with every passing moment. Consider the life cycle of a star. A star begins as a cloud of gas and dust, slowly collapsing under its own gravity. Over millions of years, it ignites, burning brightly as it fuses hydrogen into helium. For a time, it shines steadily, a beacon in the void, but eventually it runs out of fuel and its fate depends on its size. Smaller stars fade into white dwarfs, while larger ones explode in spectacular supernova, scattering their elements across the cosmos. These elements become the building blocks for new stars, planets, and even life itself. This cycle: birth, life, death, and rebirth, is a dance choreographed by time, a reminder that even the most massive structures in the universe are fleeting in the grand scheme of things. But time doesn't just shape individual stars, it influences the entire cosmos. Take the expansion of the universe, for example. Since the Big Bang, space itself has been stretching, carrying galaxies along with it. This expansion isn't just a one-time event, it's an ongoing process, driven by dark energy and measured by the passage of time. As the universe grows, galaxies move farther apart, their light stretched into longer, redder wavelengths. Over billions of years, this expansion will continue, reshaping the cosmic landscape in ways we can only begin to imagine. It's as if time is the brush that keeps adding new layers to the painting, ensuring that the universe never stops evolving. And then there's the concept of cosmic time scales. Human lives are measured in decades, but the universe operates on a vastly different timeline. Stars can burn for billions of years, galaxies collide over millions, and the universe itself is nearly 14 billion years old. These time scales are almost incomprehensible, yet they're essential to understanding the universe's artistry. They remind us that beauty isn't just about what we see in a single moment. It's about the stories that unfold over eons, the slow but steady transformation of matter and energy into something greater. So what does this mean for the cosmic artist? If the universe is a work of art, then time is its most powerful tool. It's the force that adds depth and movement, turning a static image into a living, breathing masterpiece. But it also raises a profound question. Is time simply a dimension, or is it something more? Could it be that time itself is part of the artist's palette, a medium used to create the intricate patterns and rhythms we see in the cosmos? The answer might lie in the way time interacts with the other forces of the universe, weaving together the threads of space, matter, and energy into a tapestry of infinite complexity. As we ponder the role of time in the cosmic design, we're reminded that the universe isn't just a place, it's a process, a story that's still being written. And in that story, time is the thread that connects every moment, every event, and every transformation. It's the dimension that makes the universe not just a work of art, but a living, breathing masterpiece, one that invites us to witness its beauty as it unfolds. If the universe is a grand work of art, then quantum mechanics is its abstract expression, a realm where the rules of reality bend, blur, and sometimes break. At this microscopic scale, particles don't behave like the solid, predictable objects we're used to. Instead, they exist in a state of probability, as if the universe itself is sketching multiple possibilities at once. A single electron, for example, can be in multiple places at the same time, a phenomenon known as superposition. It's as if the cosmos is an artist experimenting with countless brushstrokes, only settling on one when we stop to look. This strange, almost surreal behavior is the hallmark of quantum mechanics, and it challenges everything we thought we knew about the nature of reality. Think of it like abstract art. When you look at a painting by Jackson Pollock or Wassily Kandinsky, you don't see clear, defined shapes. Instead, you see layers of color, texture, and movement that evoke emotions and ideas without spelling them out. The meaning is open to interpretation, shaped as much by the viewer as by the artist. Quantum mechanics works in a similar way. The behavior of particles isn't fixed, it's fluid, shaped by observation and interaction. Just as an abstract painting invites you to bring your own understanding to the canvas, quantum mechanics invites us to rethink our assumptions about how the universe operates. One of the most striking examples of this is the famous double-slit experiment. When particles like electrons are fired at a barrier with two slits, they don't just pass through one or the other. They create an interference pattern, as if they're waves spreading out and interacting with themselves. But here's the twist. When scientists try to observe which slit the electron goes through, the interference pattern disappears. It's as if the act of looking collapses the particle's wave-like behavior into a single, defined path. This phenomenon, known as the observer effect, suggests that reality isn't something fixed and independent. It's something we participate in, something that shifts and changes based on how we interact with it. This idea resonates deeply with the concept of abstract art. Just as a painting's meaning can shift depending on who's looking at it, the behavior of quantum particles changes based on how we observe them. It's a reminder that reality isn't just something we experience, it's something we help create. And this isn't just a philosophical musing, it's a fundamental aspect of how the universe works at its most basic level. But quantum mechanics doesn't just challenge our understanding of reality, it also challenges our understanding of the universe's design. If particles can exist in multiple states at once, if reality is probabilistic rather than deterministic, then what does that mean for the cosmic blueprint? Does the universe have a fixed plan, or is it constantly rewriting itself, exploring endless possibilities in a dance of uncertainty and potential? Some scientists believe that quantum mechanics hints at a universe that's inherently creative, a cosmos that thrives on possibility rather than certainty. In this view, the universe isn't just a static painting, it's a living, evolving work of art, one that's constantly experimenting with new forms and patterns. And just as abstract art pushes the boundaries of what we consider beautiful, quantum mechanics pushes the boundaries of what we consider real. So, the next time you gaze at a piece of abstract art, remember this: you're not just looking at a painting. You're glimpsing a deeper truth about the universe, a truth that's as strange and beautiful as the quantum world itself. Quantum mechanics isn't just a scientific theory. It's a window into the universe's creative process, a reminder that reality is far more mysterious, more fluid, and more artistic than we ever imagined. And as we continue to explore this strange and wonderful realm, we're not just decoding the universe, we're uncovering the abstract masterpiece at the heart of existence. Now, let's shift our focus to one of the most fascinating ideas in modern physics, string theory. Imagine for a moment that the universe isn't made of solid particles, but of something far more poetic: tiny, vibrating strings. These strings, so small they're almost beyond comprehension, are the building blocks of everything we see. From the stars in the sky to the atoms in your hand, every piece of matter and energy could be, at its core, a string vibrating at its own unique frequency. It's as if the cosmos is a grand symphony, with each string playing its own note, contributing to a universal melody that we're only just beginning to hear. String theory doesn't just reimagine the universe, it redefines it. Instead of particles like electrons and quarks being tiny, solid dots, they're loops of energy vibrating in different patterns. The pitch and rhythm of these vibrations determine what kind of particle they become. A string vibrating at one frequency might be an electron, while another vibrating at a different frequency could be a photon. This idea transforms the universe from a collection of static objects into a dynamic, harmonious orchestra, where every particle is a musical note in a cosmic composition. But what makes this theory so compelling is its potential to unify the forces of nature. In the symphony of string theory, gravity, electromagnetism, and the nuclear forces aren't separate instruments, they're different harmonies played by the same strings. It's a vision of the universe where everything is interconnected, where the same fundamental rules govern both the smallest particles and the largest galaxies. This unity suggests a kind of cosmic harmony, a deep, underlying order that's as elegant as it is profound. Of course, string theory isn't without its challenges. For one, these strings are unimaginably small, so small that we may never directly observe them. And then there's the question of dimensions. String theory suggests that the universe has more than the 3 dimensions of space and one of time we're familiar with. In fact, it requires 10 or even 11 dimensions to work properly. These extra dimensions are like hidden layers in a symphony, adding depth and complexity to the music, even if we can't see or hear them directly. Yet, despite these mysteries, string theory offers a breathtaking perspective on the cosmos. It invites us to see the universe not as a static collection of objects, but as a dynamic, vibrating whole, a symphony in constant motion. And if that's true, then the cosmos isn't just a place of random events. It's a living, breathing work of art where every particle, every force, and every dimension plays a part in the grand performance. This raises a tantalizing question. If the universe is a symphony, what kind of melody is it playing? Could there be a universal rhythm, a cosmic tune that underlies everything we see? Some scientists have even speculated that the vibrations of these strings could be the key to understanding the deepest mysteries of the universe, from the nature of black holes to the origin of time itself. While we may not have all the answers yet, one thing is clear. String theory gives us a new way to listen to the cosmos, to hear the music of the spheres in a way we never could before. As we explore this idea, we're reminded that the universe is full of surprises, always ready to reveal new layers of beauty and complexity. String theory isn't just a scientific theory, It's a new lens through which we can see the cosmos, a way to appreciate its artistry on an even deeper level. And as we continue to unravel its secrets, we're not just decoding the universe, we're learning to hear its song. Black holes are often described as cosmic anomalies, regions of space where gravity is so intense that nothing, not even light, can escape their pull. But what if we've been thinking about them all wrong? What if, instead of being destructive forces, black holes are essential elements in the universe's grand design? Imagine them not as voids, but as dark masterpieces, cosmic sculptors that shape the very fabric of existence. These mysterious objects, born from the collapse of massive stars, are more than just gravitational traps. They're active participants in the universe's artistic process, influencing everything from the formation of galaxies to the flow of time itself. Take their role in galaxy formation, for instance. At the heart of nearly every large galaxy, including our own Milky Way, lies a supermassive black hole. These colossal structures, millions or even billions of times more massive than our Sun, act as gravitational anchors, pulling stars, gas, and dust into swirling orbits around them. But they're not just cosmic vacuum cleaners, they're engines of creation. As matter spirals into a black hole, it heats up, releasing enormous amounts of energy. This energy can trigger the birth of new stars, shape the structure of entire galaxies, and even influence the distribution of matter across the universe. In this way, black holes aren't just destructive, they're transformative, turning chaos into order and shaping the cosmos on a grand scale. Yet, for all their influence, the interiors of black holes remain one of the greatest mysteries in science. Beyond the event horizon, the point of no return, the rules of physics as we know them break down. Time and space become so distorted that they effectively cease to exist in any recognizable form. Some theories suggest that black holes might be gateways to other universes or dimensions, while others propose that they contain singularities, points of infinite density where the laws of physics simply don't apply. These ideas push the boundaries of our understanding, challenging us to rethink not just black holes, but the nature of reality itself. It's as if the universe has hidden its most profound secrets inside these dark enigmas, daring us to uncover them. But perhaps the most intriguing aspect of black holes is their role in maintaining cosmic balance. In a universe filled with stars, galaxies, and nebulae, black holes act as counterweights, balancing the scales of creation and destruction. They're like the shadows in a painting, essential for creating depth and contrast. Without black holes, the universe might lack the structure and dynamism that make it so breathtaking. They remind us that even in the darkest corners of space, there's a purpose, a reason why the universe is the way it is. So, the next time you think about black holes, don't just see them as cosmic vacuum cleaners or destructive forces. See them as the universe's dark masterpieces, essential elements in a grand design that's as mysterious as it is beautiful. They challenge us to look beyond the obvious, to explore the unknown, and to appreciate the balance that keeps the cosmos in harmony. And in doing so, they remind us that even in the darkest places, there's artistry waiting to be discovered. Among the countless stars in the night sky, there's a treasure trove of worlds waiting to be discovered, planets that orbit distant suns, each one a unique creation in the universe's grand design. These are exoplanets, and their discovery has revolutionized our understanding of the cosmos. Before the first exoplanet was confirmed in the early 1990s, our solar system was the only example we had of how planets form and behave. But now, thanks to powerful telescopes and innovative detection methods, we've found thousands of these distant worlds, each one offering a glimpse into the incredible diversity of the universe's artistry. From scorching gas giants orbiting close to their stars to icy worlds drifting in the darkness of deep space, exoplanets reveal a cosmos far more varied and imaginative than we ever imagined. What makes exoplanets so fascinating is their sheer variety. Some are what scientists call hot Jupiters, massive gas giants that orbit so close to their stars that their surfaces are searingly hot, their atmospheres swirling with storms and metallic clouds. Others are super-Earths, rocky worlds larger than our own, with gravity strong enough to crush anything that might try to land on them. Then there are the rogue planets, drifting through space without a star to call home, their surfaces frozen and dark, yet still holding the potential for hidden oceans beneath their icy crusts. Each of these planets is a testament to the universe's creativity, a reminder that the rules of planetary formation are more flexible and more fascinating than we once thought. But it's not just the variety of exoplanets that captivates us, it's what they tell us about the possibilities of life. Take, for example, the discovery of planets within the habitable zone, the region around a star where temperatures might allow liquid water to exist. These worlds, often referred to as Goldilocks planets, are neither too hot nor too cold, but just right for the delicate chemistry of life as we know it. Some of these planets might have atmospheres rich in oxygen, nitrogen, and even methane, hinting at the presence of complex ecosystems. Others could have vast oceans, towering mountains, or skies filled with swirling clouds of exotic gases. Each one is a blank canvas, a world waiting to tell its own story. The discovery of Earth like exoplanets raises profound questions about our place in the universe. If there are worlds out there with conditions similar to ours, could they also harbor life? And if so, what might that life look like? The search for exoplanets isn't just about finding new worlds, it's about finding new perspectives, new ways of understanding the universe and our place within it. Every Earth-like planet we discover is a reminder that our world is just one of countless possibilities, a single brushstroke in a much larger masterpiece. As we continue to explore these distant worlds, we're not just expanding our knowledge of the cosmos, we're deepening our appreciation for its artistry. Exoplanets remind us that the universe is a place of endless creativity, where every star, every planet, and every system is a unique expression of the same fundamental principles. They challenge us to think beyond our own solar system, to imagine what might be possible in the vast expanse of space, and in doing so, they invite us to see the universe not just as a collection of objects, but as a living, evolving work of art, one that's still being painted, one discovery at a time. The next time you look up at the night sky, remember this: among those stars are worlds we've only just begun to explore, each one a testament to the universe's boundless imagination. And as we uncover more of these distant treasures, we're not just decoding the cosmos, we're discovering the infinite possibilities of its design. Among the countless galaxies, stars, and planets, one question stands out. Why does the universe seem so perfectly suited for life? This is the heart of the anthropic principle, a fascinating idea that suggests the conditions of the cosmos aren't random. They're finely tuned to allow beings like us to exist. From the precise strength of gravity to the exact charge of an electron, the fundamental constants of the universe appear to be calibrated with extraordinary precision. Even the tiniest change in any of these values could render life impossible. It's as if the universe has been carefully designed to create a stage where life can emerge, evolve, and thrive. But is this a sign of deliberate intention or just a cosmic coincidence? Let's break it down. Imagine you're building a house. Every nail, beam, and window has to be just the right size and shape, or the entire structure collapses. Now think of the universe as that house. The laws of physics are the blueprint, and the constants like the speed of light or the strength of nuclear forces are the measurements. If any of these measurements were even slightly different, the house of the universe would fall apart. For example, if the gravitational constant were stronger, stars would burn out too quickly for life to develop. If it were weaker, stars might not form at all. The same goes for the other forces, electromagnetism, the strong and weak nuclear forces, even the expansion rate of the universe. Each one is set in a delicate balance, creating conditions that are just right for life to exist. But here's where it gets interesting. Some scientists argue that this apparent fine-tuning isn't evidence of design, but rather a result of the multiverse. In this view, our universe is just one of countless others, each with its own set of physical laws and constants. Most of these universes might be lifeless, their conditions too extreme or unstable to support anything. But in a few, like ours, the numbers just happen to align in a way that allows life to emerge. It's like rolling a pair of dice billions of times. Eventually, you'll get the perfect combination, even if it's purely by chance. Others, however, see the anthropic principle as a clue to something deeper. Could it be that the universe isn't just a random arrangement of forces and particles, but a carefully crafted system with a purpose? Some thinkers have even suggested that the fine-tuning of the cosmos points to the existence of a cosmic designer, a force or intelligence that set the parameters in a way that would inevitably lead to life. This idea bridges science and philosophy, inviting us to consider whether the universe is more than just a collection of physical laws, whether it's a work of art, carefully planned and executed. So, where does that leave us? If the universe is fine-tuned for life, does that mean we're the intended result, the culmination of a grand design? Or are we simply the lucky winners in a cosmic lottery? The anthropic principle doesn't give us definitive answers, but it does challenge us to think about our place in the universe in a new way. It reminds us that the cosmos isn't just a backdrop for our existence, it's deeply intertwined with the very possibility of life. This raises another question. If the universe is designed for life, what does that mean for humanity's role in the cosmic blueprint? Are we the audience here to witness the grand performance? Or are we the performers playing a part in a story that's still unfolding? Perhaps the answer lies somewhere in between. As we continue to explore the universe, we're not just observers, we're participants, shaping our understanding of the cosmos even as it shapes us. The anthropic principle invites us to see the universe not just as a place of stars and galaxies, but as a living, breathing system, one that's intricately connected to the existence of life. Whether by design or chance, the conditions of the cosmos have allowed us to emerge, to ask questions, and to marvel at the beauty of it all. And in that sense, the universe isn't just a stage, it's a story, and we're a part of it. So, as we gaze at the stars and ponder the mysteries of existence, let's remember this: the universe may be vast and ancient, but it's also deeply personal, a place where life has found a way to flourish. And in that, there's something truly extraordinary. The universe isn't a static gallery of stars and galaxies, it's a dynamic, ever-changing masterpiece, constantly in motion. Think of it as a living artwork, one that evolves over billions of years, shaped by the birth and death of stars, the collision of galaxies, and the endless recycling of matter. Every celestial event, from the fiery explosion of a supernova to the gentle drift of cosmic dust, adds a new layer to the cosmic canvas. This isn't just a universe, it's a story, a work of art that's still being created, one brushstroke at a time. Take the life cycle of a star, for example. It begins in a cloud of gas and dust, a swirling nebula where gravity slowly pulls matter together. Over millions of years, this cloud collapses, igniting the nuclear furnace at the heart of a new star. For billions of years, the star burns brightly, fusing hydrogen into helium and heavier elements, creating the building blocks of planets, moons, and even life. But stars don't last forever. When they exhaust their fuel, their fate depends on their size. Smaller stars, like our Sun, swell into red giants before shedding their outer layers, leaving behind a glowing core called a white dwarf. Larger stars, however, go out in a blaze of glory, exploding as supernova and scattering their elements across the cosmos. These stellar explosions are more than just spectacular displays, they're essential to the universe's creative process. The elements forged in the hearts of stars, carbon, oxygen, iron, and more, are flung into space, seeding the next generation of stars and planets. It's a cosmic recycling program, one that ensures the universe never runs out of raw materials. Every atom in your body, every molecule in the air you breathe, was once part of a star. In this way, the stars aren't just celestial objects, they're artists crafting the elements that make life possible. But the universe's artistry doesn't stop there. Galaxies, too, are part of this ongoing evolution. They collide, merge, and reshape themselves in a dance that spans billions of years. When two galaxies meet, their stars rarely collide. Space is too vast for that, but their gravitational forces pull and twist each other, creating stunning shapes and structures. These galactic mergers trigger bursts of star formation, lighting up the cosmos with new stars and nebulae. It's as if the universe is constantly reinventing itself, exploring new forms and patterns in an endless quest for beauty. This cosmic evolution raises a profound question. Is this constant change just a byproduct of physical laws, or is it part of the universe's artistic intent? Could the birth and death of stars, the collision of galaxies, and the recycling of matter be the universe's way of expressing itself, of creating something new and beautiful? The idea that the universe is a living artwork challenges us to see it not as a static collection of objects, but as a dynamic, creative process, a masterpiece that's always in progress. As we gaze at the night sky, we're not just looking at stars and galaxies, we're witnessing the universe's ongoing evolution, its endless journey of creation and transformation. Each star, each planet, each swirling nebula is a brushstroke in a cosmic painting that's still being painted. And in that sense, the universe isn't just a work of art, it's an artist constantly shaping and reshaping itself into something new. So, the next time you look up at the stars, remember this: you're not just observing the cosmos, you're witnessing its artistry in action, a living masterpiece that's as beautiful as it is boundless. Light plays a role far greater than simply brightening our skies. It's the universe's storyteller, revealing its secrets one wavelength at a time. From the soft glow of distant stars to the invisible hum of cosmic radiation, light carries information across unimaginable distances, painting a picture of the cosmos that we can decode with the right tools. Without light, the universe would remain a mystery, its beauty and structure hidden in darkness. But thanks to telescopes and other instruments, we've learned to see the cosmos in ways our ancestors could never have imagined. Think about starlight, for instance. When we gaze at a star, we're not just seeing a point of light, we're receiving a message from across space and time. The light from that star has traveled millions, even billions of years to reach us, carrying clues about its composition, temperature, and age. By analyzing the spectrum of starlight, breaking it into its component colors, scientists can determine what elements are present in a star's atmosphere. It's like reading a cosmic fingerprint, one that tells the story of how stars are born, live, and die. But starlight is just the beginning. Telescopes like Hubble and James Webb have opened our eyes to the universe's full spectrum of light, from the infrared to the ultraviolet. These instruments act as cosmic translators, converting wavelengths invisible to the human eye into images we can understand and appreciate. Through their lenses, we've seen the birth of stars in glowing nebulae, the collision of galaxies in swirling clouds of gas, and the eerie glow of black holes devouring their surroundings. Each image is a revelation, a glimpse into processes that shape the universe on the grandest scales. Yet there's more to light than meets the eye, literally. Beyond the visible spectrum lies a world of unseen wavelengths, each one holding its own secrets. Take cosmic microwave background radiation, for example. This faint glow, the afterglow of the Big Bang, is invisible to our eyes but detectable by specialized instruments. It's a time capsule from the early universe, offering clues about its origins and evolution. Then there's X-ray and gamma-ray radiation, emitted by some of the most energetic events in the cosmos: supernova, black holes, and neutron stars. These high-energy wavelengths reveal the violent, dynamic side of the universe, a side we'd never see with just our eyes. The study of light has even led us to discover phenomena we couldn't have predicted. Gravitational lensing, for instance, occurs when the light from a distant object is bent by the gravity of a massive object in its path, like a galaxy or a black hole. This effect, predicted by Einstein's theory of relativity, acts like a natural telescope, magnifying and distorting the light from objects too far away to see otherwise. It's a cosmic trick of the light, one that allows us to peer deeper into the universe than ever before. But as much as light reveals, it also hints at what remains hidden. The universe is filled with wavelengths we've only begun to explore, from the faint whispers of neutrinos to the gravitational waves rippling through space-time. These unseen signals could hold the key to understanding the universe's most profound mysteries: dark matter, dark energy, and the very fabric of reality itself. Light in all its forms is more than just a tool for observation. It's a bridge between us and the cosmos. It connects us to the stars, to the galaxies, and to the vast, intricate web of existence. Through light, we've learned to see the universe not as a static, unchanging void, but as a dynamic, evolving masterpiece filled with beauty, complexity, and endless wonder. And as we continue to explore its many wavelengths, we're reminded that the universe still has so much more to reveal if only we know how to look. So, the next time you gaze at the night sky, remember this: every beam of light, every shimmering star is part of a much larger story. It's a story written in the language of photons, one that we're only just beginning to understand. And as we decode this cosmic language, we're not just observing the universe, we're learning to see its artistry in a whole new light. Gravity is more than just the force that keeps your feet on the ground. It's the invisible hand that shapes the universe itself. From the smallest particles to the largest galaxies, gravity is the sculptor of the cosmos, molding matter into intricate structures and guiding the motion of celestial bodies. Without gravity, the universe would be a formless void, a blank canvas without shape or structure. It's the force that pulls stars together into galaxies, binds planets into orbits, and even bends the very fabric of space-time. In this sense, gravity isn't just a law of physics. It's the artist's tool, carving order out of chaos and giving the universe its breathtaking form. Picture a galaxy, its spiral arms swirling gracefully through space. This iconic shape isn't an accident, it's the result of gravity's relentless pull. Billions of stars, gas clouds, and dark matter are held together by gravity, spinning in a delicate balance that creates the galaxy's elegant structure. The same force that keeps Earth orbiting the Sun also shapes the vast, luminous arcs of galaxies millions of light-years across. It's as if gravity is a cosmic sculptor, patiently shaping the universe over billions of years, one star at a time. But gravity's influence doesn't stop at the galactic scale. It's also the force that shapes the orbits of planets, moons, and asteroids. Take our solar system, for example. The Sun's gravity acts like an anchor, holding the planets in their elliptical paths. Without it, Earth would drift aimlessly into the void, a lonely wanderer in the darkness. Gravity's pull creates the rhythmic dance of the planets, a celestial ballet that's been playing out for billions of years. And it's not just planets. Gravity also shapes the paths of comets, the rings of Saturn, and even the tides on Earth, reminding us that its reach extends far beyond the stars. What's truly remarkable, though, is how gravity's influence stretches beyond what we can see. Take dark matter, for instance. This mysterious substance doesn't emit light, but its gravitational effects are undeniable. Without dark matter, galaxies would fly apart, their stars scattering into the void. It's like the invisible scaffolding of the universe, holding everything together even as it remains hidden from view. Then there's the way gravity bends light itself, a phenomenon known as gravitational lensing. Massive objects like galaxies and black holes act as cosmic magnifying glasses, warping the light from distant stars and galaxies and revealing hidden corners of the universe we might otherwise never see. Gravity's role in the cosmos is both profound and pervasive. It's the force that shapes the universe on every scale, from the orbits of planets to the structure of galaxies. But it's also a reminder of how much we still have to learn. While we understand the basics of gravity, its deeper mysteries like its connection to quantum mechanics or its role in the early universe remain unsolved. These unanswered questions add another layer to gravity's story, inviting us to keep exploring, keep questioning, and keep marveling at the universe's intricate design. So, the next time you feel the pull of gravity beneath your feet, remember this: you're experiencing the same force that shapes the cosmos. It's the thread that weaves the universe together, connecting everything from the smallest grain of dust to the largest galaxy. And in that connection, we find not just the beauty of the universe, but the unity of its design, a testament to the power and artistry of gravity, the force that sculpts the stars. When we think of collisions, we often imagine destruction, a chaotic, violent process that leaves nothing but ruins in its wake. But in the cosmos, collisions are something far more profound. They're moments of transformation where destruction and creation collide in a breathtaking dance. From the merging of galaxies to the impact of asteroids, these events are the universe's way of reinventing itself, turning chaos into opportunity and reshaping the cosmic landscape in ways we're only beginning to understand. Take galaxy mergers, for example. When two galaxies collide, it's one of the most dramatic events in the universe. Stars, gas, and dust are flung into chaotic orbits, creating swirling patterns and explosive bursts of energy. But here's the twist: these collisions rarely result in actual crashes between stars. Space is so vast that stars pass by each other like ships in the night. Instead, it's the gravitational forces at play that truly transform these galaxies. The immense pull of one galaxy on another bends and twists their structures, triggering waves of star formation and igniting brilliant nebulae. What begins as a chaotic encounter ends in a stunning display of cosmic artistry, as new stars are born and galaxies are reborn in entirely new forms. Then there are asteroid impacts, smaller in scale but no less impactful. On Earth, we've seen the scars left by these collisions, from the massive Chicxulub crater in Mexico to the Barringer crater in Arizona. These events are often seen as destructive, and rightly so. They've shaped the course of life on our planet in dramatic ways, but even here, destruction is just one side of the story. Asteroid impacts have delivered water and organic molecules to Earth, seeding the planet with the ingredients for life. They've also reshaped landscapes, creating new habitats and opportunities for evolution. In this sense, every collision is a catalyst, a moment of upheaval that opens the door to new beginnings. But perhaps the most striking example of cosmic collisions lies in the early universe. During its infancy, the cosmos was a chaotic, crowded place, filled with dense clouds of gas and young, energetic stars. Collisions were frequent, and they played a crucial role in shaping the universe we see today. When massive stars collided, they sparked supernova, scattering heavy elements like carbon, oxygen, and iron into space. These elements became the building blocks for new stars, planets, and eventually life itself. Without these early collisions, the universe would lack the complexity and diversity we see today. This interplay between destruction and creation is a recurring theme in the cosmos. Collisions may appear destructive, but they're also essential to the universe's creative process. They're the moments when old structures break down, making way for new ones to emerge. They remind us that chaos isn't the enemy of beauty. It's a vital part of it, a force that drives the universe to evolve, adapt, and grow. So, the next time you look at a galaxy or ponder the scars on a planet's surface, remember this: what seems like destruction is often just the first step in a much larger story. Collisions are the universe's way of pushing boundaries, of exploring new possibilities, and of creating something extraordinary out of the chaos. In the grand design of the cosmos, even the most dramatic moments are part of a delicate balance, a balance that keeps the universe alive, vibrant, and endlessly fascinating. The search for extraterrestrial life is one of the most profound and tantalizing quests in human history. What if life isn't unique to Earth? What if, scattered across the cosmos, there are other civilizations gazing up at their own night skies, pondering the same questions we are? The idea of life beyond our planet challenges us to expand our understanding of the universe's artistry, not just as a canvas of stars and galaxies, but as a stage for the emergence of consciousness itself. If the universe is a grand work of art, then life could be its most intricate and awe-inspiring masterpiece. Think about it. Every living thing on Earth is a product of the same cosmic processes that shape the stars. The carbon in your cells, the oxygen in your breath, even the iron in your blood, all of it was forged in the hearts of ancient stars and scattered across the cosmos by supernova. Life, in this sense, is the universe's way of turning stardust into something extraordinary, a living, breathing expression of its creativity. But if life emerged here on this small blue planet, why couldn't it have emerged elsewhere? The ingredients are everywhere: water, organic molecules, and the energy of stars. The universe seems to have all the tools it needs to create life, not just once but countless times. The search for extraterrestrial life has taken many forms, from the microscopic to the cosmic. On Mars, rovers like Curiosity and Perseverance scour the surface for signs of ancient microbial life, searching for clues in the planet's rocky terrain. Beyond our solar system, telescopes like Kepler and TESS have discovered thousands of exoplanets, some of which lie in the habitable zone, where conditions might be just right for liquid water and perhaps life to exist. And then there's the search for intelligent life, listening for signals from distant civilizations through projects like SETI. Each of these efforts is a step toward answering one of humanity's oldest questions: are we alone? But what if we're not? What if, out there among the stars, there are other beings contemplating the universe in ways we can't even imagine? How might they perceive the cosmos? Would they see the same patterns we do, the fractals, the golden ratio, the symmetry? Or would their understanding of the universe's design be entirely different? The possibility of extraterrestrial civilizations invites us to consider not just the science of life, but the philosophy of it. Are we all part of the same cosmic story, or are there countless stories unfolding across the universe, each one unique and beautiful in its own way? This search also raises a deeper question: is life a universal phenomenon, a natural outcome of the universe's creative processes, or is Earth a rare, even unique, oasis in the vastness of space? The answer could reshape not just our understanding of the cosmos, but our place within it. If life is common, then the universe might be teeming with creativity, a living, breathing gallery of countless worlds and civilizations. But if it's rare, then Earth becomes all the more precious, a singular masterpiece in an otherwise silent void. As we continue to explore the cosmos, we're not just searching for life, we're searching for meaning. The discovery of extraterrestrial life would be a revelation, a moment that transforms how we see ourselves and our place in the universe. It would remind us that the cosmos isn't just a collection of stars and galaxies. It's a living, evolving work of art, one that invites us to look deeper, dream bigger, and marvel at the infinite possibilities of existence. So, as we peer into the vastness of space, let's keep asking the big questions. Is life a universal phenomenon woven into the very fabric of the cosmos? Or are we the universe's way of discovering itself, a fleeting moment of consciousness in an endless sea of stars? The answers may lie hidden in the stars, waiting for us to find them. And in that search, we're not just exploring the universe, we're exploring the very nature of life itself. Mathematics is often called the language of the universe, and for good reason. It's the tool we use to decode the cosmos, to uncover the patterns and laws that govern everything from the smallest particles to the largest galaxies. Think of it as a hidden code written into the fabric of reality itself, a code that allows us to understand the universe in ways that would otherwise be impossible. From the graceful arcs of planetary orbits to the chaotic swirls of nebulae, mathematics provides the framework that makes sense of it all. But here's the remarkable thing: this code isn't just a human invention. It's something far deeper, something that seems to exist independently of us, waiting to be discovered. Take Einstein's theory of relativity, for example. This elegant set of equations describes how gravity works, not as a force, but as the curvature of space-time itself. It's a concept that's almost poetic in its simplicity, yet it explains everything from the bending of light around massive objects to the precise ticking of GPS satellites. Or consider Schrödinger's equation, which describes the behavior of particles at the quantum level. This equation doesn't just predict where a particle might be, it describes the probability of finding it in a particular state, opening a window into the strange, probabilistic world of the very small. These equations aren't just abstract ideas, they're the keys that unlock the mysteries of the universe. But what makes mathematics so uniquely suited to describing the cosmos? Some argue that it's because mathematics is a fundamental aspect of reality, a universal language that exists whether or not humans are here to interpret it. After all, the laws of physics don't change because we observe them. The speed of light, the pull of gravity, the behavior of particles, these are constants, written into the fabric of the universe long before humans ever walked the earth. In this view, mathematics isn't something we invented, it's something we discovered, a pre-existing framework that the universe itself follows. Others, however, see mathematics as a human creation, a tool we've developed to make sense of the world around us. After all, the equations we use are shaped by our perceptions, our limitations, and even our cultural biases. The way we describe the universe through numbers, symbols, and equations is a reflection of how we think, not necessarily how the universe is. This perspective raises a fascinating question. If mathematics is a human invention, could there be other ways of understanding the cosmos, ways that are completely foreign to our way of thinking? This debate isn't just academic, it's deeply connected to how we see the universe and our place within it. If mathematics is a fundamental aspect of reality, then the universe is inherently ordered, governed by rules that are universal and unchanging. But if it's a human invention, then the universe might be far more complex, even mysterious, than we can ever fully comprehend. Either way, one thing is clear: mathematics is an extraordinary tool, one that allows us to glimpse the inner workings of the cosmos and to marvel at its elegance and complexity. So, the next time you look at an equation, whether it's the simplicity of E equals mc squared or the intricate beauty of a fractal, remember this: you're not just looking at a collection of symbols. You're looking at the universe's hidden code, a language that connects us to the stars, to the galaxies, and to the very essence of existence. And as we continue to explore this language, we're not just decoding the cosmos, we're learning to speak its deepest truths. When we think of the universe, we often picture stars scattered across a dark void, islands of light in an endless sea, but the truth is far more intricate. The cosmos isn't just a random scattering of stars and galaxies, it's a vast, interconnected network, a cosmic web that stretches across the universe. This web, made up of galaxies, dark matter, and immense voids, is one of the most awe-inspiring structures in existence. It's not just a collection of objects, it's a living, breathing system, a network so complex that it mirrors the branching patterns of a neural network or the delicate threads of a spider's web. At the heart of this structure is dark matter, the invisible force that holds everything together. While we can't see it directly, its gravitational influence is undeniable. Dark matter acts like the scaffolding of the cosmic web, pulling galaxies into long, filament-like strands that intersect at dense nodes. These nodes are where galaxy clusters form, immense gatherings of hundreds or even thousands of galaxies bound together by gravity. Between the strands lie vast, empty voids, regions of space so sparse that they can stretch for hundreds of millions of light years. Together, these filaments and voids create a web-like structure that spans the entire universe, a tapestry of light and shadow woven on the grandest scale imaginable. What's truly fascinating is how this cosmic web resembles structures we see in nature and even in ourselves. The branching filaments of dark matter and galaxies echo the intricate pathways of a neural network, the way information travels through the brain. They also mirror the delicate strands of a spider's web, each thread carefully placed to create a balance of strength and flexibility. This resemblance isn't just coincidence, it's a reflection of the universal principles that govern how systems organize themselves from the smallest scales to the largest. But how did this cosmic web come to be? The answer lies in the early universe, in the faint ripples of density left over from the Big Bang. These ripples, tiny fluctuations in the distribution of matter, grew over billions of years, pulled by gravity into the intricate patterns we see today. It's a process that's still ongoing as galaxies continue to move along the web's filaments, drawn toward the densest nodes like cosmic travelers on an endless journey. Yet for all we've learned, the cosmic web remains shrouded in mystery. What role does dark energy play in shaping its structure? How do galaxies evolve as they move through the web? And what secrets might the voids hold, those vast, empty regions that seem to defy our understanding? These questions remind us that the cosmic web isn't just a structure, it's a story, one that's still being written. As we gaze at this immense network, we're reminded of the universe's interconnectedness. The cosmic web isn't just a collection of galaxies, it's a testament to the forces that shape the cosmos, a reminder that even in the vastness of space, everything is connected. And in that connection, we find not just beauty, but a deeper understanding of the universe's grand design, a design that invites us to keep exploring, keep questioning, and keep marveling at the infinite complexity of existence. What if the universe isn't just a grand work of art? What if we are part of the masterpiece? Human consciousness, with its ability to observe, think, and wonder, might be more than just a byproduct of evolution. Could it be that consciousness is woven into the very fabric of the cosmos, an essential thread in the tapestry of existence? This idea, as bold as it sounds, has been explored by scientists, philosophers, and thinkers across disciplines, each offering a glimpse into the possibility that the universe isn't just something we observe, it's something we participate in. One intriguing theory comes from the world of quantum mechanics. The observer effect, as we've touched on before, suggests that the act of observation can influence the behavior of particles. In other words, the universe might not fully decide how to behave until it's being watched. This has led some to speculate that consciousness itself could play a role in shaping reality. Imagine the universe as a canvas and consciousness as the brush, a force that brings form and meaning to the otherwise abstract. While this idea is still highly debated, it raises profound questions about our place in the cosmos. Are we passive observers, or are we active participants in the universe's unfolding story? Another perspective comes from the concept of panpsychism, the idea that consciousness is a fundamental aspect of the universe, much like space, time, or energy. In this view, even the smallest particles might possess a rudimentary form of awareness, and the complexity of human consciousness emerges as these basic elements combine and evolve. Think of it like this: if the universe is a symphony, then consciousness could be the underlying harmony that ties everything together, from the tiniest atom to the vastest galaxy. While this might sound like science fiction, it's a serious topic of discussion among philosophers and physicists, offering a radical reimagining of what it means to exist. But let's take it a step further. Some theories go as far as to suggest that the universe itself might be self-aware, a conscious entity capable of reflecting on its own existence. This idea, sometimes called the self-aware universe hypothesis, proposes that the cosmos isn't just a collection of stars and galaxies, but a living, thinking system. In this view, the emergence of conscious beings like us could be the universe's way of understanding itself, of experiencing its own beauty and complexity through the lens of life. It's a poetic thought, one that blurs the line between the observer and the observed, the creator and the creation. What does this mean for our understanding of existence? If consciousness is indeed an integral part of the universe's design, then our role might be far more significant than we ever imagined. We're not just passive witnesses to the cosmos, we're active contributors, shaping reality even as we seek to understand it. This shifts the narrative from one of isolation to one of connection, reminding us that we're deeply intertwined with the universe in ways we're only beginning to comprehend. So, as we ponder the mysteries of consciousness, let's consider this. If the universe is a grand work of art, then perhaps we're not just the audience, we're part of the masterpiece itself. Our thoughts, our awareness, our very existence might be brushstrokes on the cosmic canvas, adding depth and meaning to the universe's endless story. And in that story, we find not just answers, but a profound sense of belonging. A reminder that we're not separate from the cosmos, but an essential part of its beauty, complexity, and wonder. As we marvel at the universe's beauty and complexity, it's natural to wonder, how will it all end? The cosmos, for all its grandeur, isn't eternal. Like any great work of art, it has a beginning, a middle, and, inevitably, an end. But what will that final act look like? Will the universe fade into silence, collapse back on itself, or transform into something entirely new? The answers lie in some of the most intriguing theories in modern cosmology, each one offering a unique vision of the universe's ultimate fate. One of the most widely accepted theories is the concept of heat death. Picture a universe that's been expanding for trillions of years, its stars burning out one by one, its galaxies drifting farther and farther apart. Over time, all the energy that fuels stars, planets, and even black holes will be exhausted. The universe will grow cold and dark, a vast, empty expanse where no new stars are born, no planets orbit, and no life stirs. It's a somber vision, one where the universe's vibrant tapestry fades into a quiet, featureless void. But even in this stillness, there's a kind of eerie beauty, a final, frozen moment in the cosmic story. Another possibility is the Big Crunch. Imagine the opposite of the Big Bang. Instead of expanding forever, the universe's growth slows, stops, and then reverses. Galaxies begin to move closer together, pulled by gravity into a cosmic embrace. Eventually, everything, stars, planets, even space itself, collapses into a single, infinitely dense point. It's a dramatic ending, one that echoes the explosive beginning of the universe. But here's the twist. Some scientists suggest that this collapse could trigger a new Big Bang, starting the cycle all over again. In this view, the universe isn't just a linear story, it's a loop, endlessly repeating itself in a dance of creation and destruction. Then there's the Big Rip. In this scenario, dark energy, the force driving the universe's accelerated expansion, becomes so powerful that it tears apart everything in its path. First, galaxies are ripped apart, then stars, then planets, and finally, even atoms are pulled asunder. It's a violent, chaotic end, one that leaves the universe in shreds. Yet, even here, there's a strange kind of symmetry. If the universe began with a single, explosive moment, perhaps it's fitting that it ends with one as well, a final, dramatic stroke on the cosmic canvas. These theories aren't just scientific speculation, they're reflections of the universe's cyclical nature. Creation and destruction, expansion and contraction, order and chaos. These are the forces that shape the cosmos, from the smallest particles to the largest galaxies. They remind us that the universe isn't static, it's dynamic, always in motion, always changing. Even its end isn't truly an end, it's a transformation, a shift from one state to another. So, what does this mean for the cosmic masterpiece? If the universe is a work of art, then its end might be the final brushstroke, the moment when the artist steps back and declares the piece complete. But even then, the story doesn't truly end. In the heat death, the big crunch, or the big rip, the universe's legacy lives on in the stars that once shone, the galaxies that once danced, and the life that once thrived. As we contemplate the universe's fate, we're reminded of its profound interconnectedness. Every ending is also a beginning, every destruction a chance for renewal. The universe's final act might be a moment of stillness, a collapse, or a dramatic explosion, but in each case, it's part of a larger, ongoing story. A story that's as mysterious as it is beautiful, as fleeting as it is eternal. And in that story, we find not just the end of the universe, but the enduring power of its artistry. Art and science have often been seen as separate realms, one grounded in imagination, the other in observation. But what if the boundaries between these disciplines aren't as rigid as they seem? The idea of the universe as a grand work of art offers a unique bridge between the two, revealing how creativity and curiosity are not just connected, but fundamentally intertwined. Take Vincent van Gogh's Starry Night, for instance. This iconic painting, with its swirling skies and radiant stars, is more than just a masterpiece of emotion. It's a reflection of the cosmos itself. Van Gogh didn't just paint what he saw, he captured the feeling of the night sky, its mystery and motion, in a way that resonates with scientists and stargazers alike. This connection between art and science isn't limited to the past. Modern astrophysicists often describe their work in terms that sound almost poetic. They speak of galaxies as islands of light and black holes as cosmic symphonies, using language that evokes both wonder and precision. And why not? The universe is as much a source of inspiration for artists as it is a subject of study for scientists. The vibrant colors of nebulae, the intricate patterns of fractal geometry, even the haunting beauty of a supernova, these are all phenomena that captivate the imagination, sparking creativity across disciplines. But the interplay between art and science goes deeper than inspiration. It's about perspective. Scientists approach the cosmos with tools and equations, seeking to uncover its laws and mechanisms. Artists, on the other hand, explore its meaning and emotion, using color, form, and movement to express what can't always be measured. Together, these approaches create a fuller picture of the universe, one that's not just understood but felt. For example, the Hubble Space Telescope's images of distant galaxies are stunningly beautiful, but they're also rich with scientific data. Artists and designers often collaborate with scientists to transform this data into visual representations that make complex concepts accessible to everyone. This interdisciplinary approach doesn't just enrich our understanding of the cosmos, it also highlights the shared humanity behind both art and science. At their core, both disciplines are driven by curiosity, by a desire to explore the unknown and make sense of the world around us. Whether it's a painter capturing the essence of a starry sky or a physicist unraveling the mysteries of dark matter, the goal is the same: to connect with something greater than ourselves, to find meaning in the vast, intricate tapestry of existence. By embracing this connection, we open ourselves to new ways of seeing and thinking. The universe isn't just a collection of stars and equations. It's a story, a symphony, a work of art in progress. And as we continue to explore its wonders, we're reminded that the lines between disciplines are fluid, not fixed. In the end, whether through the lens of a telescope or the stroke of a brush, the cosmos invites us to marvel, to question, and to create, not as separate fields, but as facets of the same quest for understanding. This blending of art and science doesn't just deepen our appreciation of the universe, it also enriches our experience of it. It reminds us that the cosmos isn't just something to be studied, it's something to be felt, to be lived. And in that shared journey, we find not just answers, but a profound sense of connection to each other, to the universe, and to the endless possibilities of discovery. Humanity's understanding of the cosmos has always been shaped by the tools we create. From the earliest stargazers who relied on nothing more than their eyes and curiosity to the cutting-edge technology of today, our ability to explore the universe has grown exponentially. Telescopes, space probes, and advanced imaging systems have become our eyes and hands in the void, allowing us to see farther, understand deeper, and decode the celestial blueprint in ways that were once unimaginable. These tools don't just extend our vision, they transform it, revealing a universe that's far more complex, beautiful, and mysterious than we ever dreamed. The journey began centuries ago with the invention of the telescope, a device that forever changed our relationship with the night sky. When Galileo first pointed his rudimentary telescope toward the heavens in the early 17th century, he saw something extraordinary: the craters of the moon, the moons of Jupiter, and countless stars invisible to the naked eye. It was a revelation, a moment when the universe suddenly became larger, stranger, and more intricate than anyone had imagined. Since then, telescopes have evolved from simple lenses to massive observatories like Hubble and James Webb, which peer into the farthest reaches of space and time. These instruments don't just capture light, they capture history, allowing us to look back billions of years to the universe's earliest moments. But telescopes are only part of the story. Space probes like Voyager, Cassini, and New Horizons have taken us on journeys across the solar system, bringing distant worlds into sharp focus. Thanks to these robotic explorers, we've seen the icy geysers of Enceladus, the swirling storms of Jupiter, and the frozen plains of Pluto. Each mission adds a new chapter to our understanding of the cosmos, revealing landscapes and phenomena that challenge our assumptions and spark our imagination. These probes are more than just machines, they're extensions of our curiosity, carrying humanity's desire to explore into the farthest reaches of space. And then there's the role of advanced imaging and data analysis. Modern telescopes don't just capture visible light, they observe the universe across the electromagnetic spectrum, from radio waves to gamma rays. This allows us to see things that would otherwise remain hidden: black holes warping space-time, nebulae glowing with the birth of new stars, and galaxies colliding in violent, beautiful displays. Meanwhile, algorithms and artificial intelligence help us sift through mountains of data, uncovering patterns and connections that might otherwise go unnoticed. Together, these tools provide a multi-dimensional view of the universe, one that's richer and more nuanced than anything we could achieve with our eyes alone. As we look to the future, the possibilities are even more exciting. Groundbreaking projects like the extremely large telescope, set to begin operations later this decade, promise to revolutionize our understanding of exoplanets and distant galaxies. Missions like the James Webb Space Telescope are already revealing the atmospheres of distant worlds, offering clues about their potential for life. And beyond that, concepts like interstellar probes and space-based interferometers hint at a future where humanity's reach extends far beyond our solar system, into the uncharted territories of the cosmos. This ever-expanding vision of the universe is a testament to human ingenuity and our unrelenting desire to explore. Each new tool, each new discovery, is a step toward understanding the celestial blueprint, not just as a static map, but as a dynamic, evolving work of art. And as we continue to push the boundaries of technology, we're reminded that the universe still has so much to reveal. The tools we create aren't just instruments, they're bridges connecting us to the stars and inviting us to see the cosmos in ways we've never imagined. The future of cosmic exploration isn't just about better telescopes or faster probes, it's about redefining what's possible. It's about harnessing the power of innovation to unlock the universe's deepest secrets, to see the invisible and to explore the unknown. And in that journey, we're not just observers, we're participants, shaping the story of the cosmos even as we strive to understand it. The universe may be vast, but with every leap in technology, it feels a little closer, a little more within our grasp. And that, perhaps, is the greatest gift of all, a reminder that the cosmos isn't just something we look at. It's something we're a part of. The cosmos, with its swirling galaxies and intricate patterns, invites us to ask questions that go beyond the realm of science. What does it all mean? Is there a purpose behind the universe's grandeur, or is it simply a stunning accident? These are the kinds of questions that bridge the gap between science and philosophy, inviting us to explore not just how the universe works, but why it exists at all. When we view the cosmos as a work of art, we're not just observing its beauty, we're contemplating its meaning and perhaps even our place within it. Beauty, for instance, is a concept that often feels deeply personal, yet it seems to resonate across the universe. From the golden spirals of galaxies to the perfect symmetry of snowflakes, nature is filled with patterns that feel inherently pleasing to us. But is beauty just a human construct, or does it have a deeper, universal significance? Some scientists and philosophers argue that beauty might be a kind of universal language, a way for the cosmos to express its underlying order. In this view, the elegance of a mathematical equation or the harmony of a planetary orbit isn't just aesthetically pleasing, it's a reflection of the universe's intrinsic design. Then there's the question of purpose. If the universe is a grand work of art, does that imply an artist? Some see the intricate balance of physical constants, the fine-tuning that allows life to exist, as evidence of intentional design. Others argue that the universe's apparent order is simply the result of natural processes, a cosmic lottery where the conditions for life happen to align. Both perspectives raise fascinating questions about whether the cosmos has a goal or if it's simply unfolding according to its own rules, indifferent to the life it contains. Meaning, too, is a concept that takes on new dimensions when we consider the universe as art. For centuries, humans have looked to the stars for guidance, weaving stories and myths that give shape to the chaos of existence. In a way, we've always used the cosmos as a mirror, reflecting our own hopes, fears, and questions. But if the universe is a masterpiece, what does it say about the meaning of our lives? Are we mere observers, or do we play a role in the unfolding narrative? Some thinkers suggest that meaning isn't something we discover. It's something we create through our actions, our curiosity, and our connection to the cosmos. These philosophical questions don't just deepen our understanding of the universe, they shape how we perceive reality itself. When we see the cosmos as a work of art, we're reminded that reality isn't just a collection of facts and figures. It's a rich, layered experience that invites interpretation. The patterns we find, the beauty we admire, and the meaning we seek are all part of a larger dialogue between us and the universe. It's a dialogue that doesn't always provide clear answers, but it does something even more profound. It keeps us asking questions. So, as we continue to explore the cosmos, let's not forget to embrace the philosophical journey alongside the scientific one. The universe isn't just a puzzle to solve, it's a story to interpret, a mystery to wonder at. And in that wonder, we find not just the beauty of the cosmos, but the beauty of being human, of having the capacity to look up at the stars and ask, what does it all mean? There's something profoundly human about standing beneath a starry sky, feeling both insignificant and deeply connected to something vast and mysterious. That sense of wonder, the awe that comes from gazing into the unknown, is more than just a fleeting emotion. It's a driving force, the spark that has propelled humanity's greatest discoveries and deepest reflections. Wonder isn't just a reaction to the cosmos, it's a lens through which we can see it more clearly, a tool that helps us navigate the mysteries of existence. Think about the first time you truly noticed the night sky. Maybe it was a camping trip far from city lights or a quiet moment in your backyard. That feeling of being small yet part of something immense, it's universal. It's what led ancient civilizations to chart the stars, to create myths and stories that gave meaning to the heavens. It's what inspired Galileo to point his telescope skyward, revealing moons around Jupiter and forever changing our understanding of the cosmos. Wonder isn't just about what we know, it's about what we don't know and the endless possibilities that lie beyond our current understanding. Embracing the unknown isn't just an act of curiosity, it's an act of courage. It means being comfortable with questions that don't yet have answers, with mysteries that might never be fully solved. Take dark matter, for example. We know it exists because of its gravitational effects, but we can't see it, touch it, or even fully explain it. Instead of being frustrated by this gap in our knowledge, scientists have used it as a springboard for discovery, developing new theories and technologies to probe the unseen. This is the power of wonder. It transforms the unknown from a barrier into a doorway, inviting us to explore, to experiment, and to imagine. But wonder isn't just for scientists. It's for all of us. When we allow ourselves to be amazed by the universe, we open ourselves to new ways of thinking and seeing. A child marveling at the phases of the moon, an artist capturing the swirl of a nebula, a philosopher pondering the nature of existence. Each of these is an expression of wonder, a way of engaging with the cosmos that goes beyond facts and figures. Wonder connects us to the universe on an emotional level, reminding us that we're not just passive observers, but active participants in a grand, unfolding story. This connection is what makes wonder so vital to our understanding of the cosmos. It's not just about finding answers, it's about asking better questions. Why does the universe have the structure it does? What lies beyond the edge of our observable universe? Are we alone, or is there life out there, gazing back at us with the same sense of awe? These questions don't just drive scientific inquiry, they inspire art, philosophy, and even spirituality. They remind us that the universe isn't just something to be studied, it's something to be experienced, to be felt, to be lived. So, as we continue to explore the cosmos, let's not lose sight of the wonder that started it all. It's easy to get caught up in the details, the equations, the data, the theories, but at the heart of it all is that same spark of curiosity that's been with us since the dawn of humanity. Wonder is the key that unlocks the universe's secrets, not because it gives us all the answers, but because it keeps us asking the right questions. And in those questions, we find not just knowledge, but a deeper appreciation for the beauty, complexity, and mystery of existence itself. The universe is vast, intricate, and endlessly fascinating, but perhaps its greatest gift is the sense of wonder it inspires in us, a reminder that no matter how much we learn, there will always be more to discover, more to marvel at, and more to dream about. And in that endless exploration, we find not just the secrets of the cosmos, but the essence of what it means to be human. Imagine standing at the crossroads of art and science, where the precision of mathematics meets the boundless creativity of the human mind. This intersection isn't just a meeting point, it's a launching pad for new ways of understanding the universe. When we bring together the analytical rigor of science and the expressive freedom of art, we unlock a perspective that's richer, more nuanced, and infinitely more inspiring. It's not about choosing one over the other. It's about realizing how these disciplines can amplify each other, revealing truths that neither could uncover alone. Take the work of Leonardo da Vinci, for example. He wasn't just an artist or a scientist, he was both. His sketches of the human body weren't merely artistic masterpieces. They were groundbreaking studies of anatomy, revealing insights that would shape medical science for centuries. His designs for flying machines, though never built in his lifetime, were rooted in meticulous observations of nature, blending art and engineering in a way that felt almost prophetic. Da Vinci understood that creativity and curiosity aren't separate paths, they're two sides of the same coin, each fueling the other in a continuous cycle of discovery. This synergy between art and science isn't confined to history. Modern scientists often draw on artistic principles to communicate complex ideas. Think of the stunning visualizations of black holes or the intricate models of DNA. These aren't just tools for education, they're works of art in their own right, transforming abstract concepts into something tangible and beautiful. At the same time, artists are increasingly using scientific methods and technologies to push the boundaries of their craft. From digital art powered by algorithms to installations that incorporate live data from space, the line between the two fields is becoming beautifully blurred. But this convergence isn't just about aesthetics or innovation, it's about perspective. Science gives us the tools to understand the universe, but art gives us the language to interpret it. When we look at a spiral galaxy, a physicist might see the result of gravitational forces, while an artist might see a cosmic dance, a swirl of light and energy that evokes emotion and wonder. Both views are valid, and together they create a fuller, more vibrant picture of reality. This interdisciplinary approach doesn't just enhance our understanding, it also sparks new ideas, leading to breakthroughs that might never have happened in isolation. Consider the field of astrobiology, for instance. Scientists studying the potential for life beyond Earth often collaborate with artists to imagine what extraterrestrial ecosystems might look like. These collaborations don't just produce speculative art, they inspire new hypotheses, challenging researchers to think outside the box and consider possibilities they might have otherwise overlooked. Similarly, artists working with quantum physicists have created installations that explore the strange, probabilistic nature of reality, making the abstract tangible and inviting viewers to engage with concepts that might otherwise feel inaccessible. This interplay between art and science also has a profound impact on how we approach problems. Interdisciplinary thinking encourages us to see connections where others might see divisions, to find solutions that are as imaginative as they are effective. It's a reminder that creativity isn't just the domain of artists, it's a fundamental part of the scientific process, a way of reimagining the world and our place within it. So, as we explore the universe, let's not limit ourselves to a single lens. By embracing the intersection of art and science, we open ourselves to a more holistic understanding of the cosmos, one that's as rich in meaning as it is in detail. This approach doesn't just deepen our knowledge, it enriches our experience, reminding us that the universe isn't just something to be studied, it's something to be felt, to be marveled at, and to be celebrated. And in that celebration, we find not just answers, but a renewed sense of wonder and possibility. The future of cosmic exploration is unfolding before our eyes, and it's more exciting than ever. Imagine stepping onto the surface of Mars, feeling the red dust crunch beneath your boots, and gazing at Earth as a tiny blue dot in the sky. This isn't science fiction, it's a vision that could become reality within our lifetimes. Missions like NASA's Artemis program and SpaceX's Starship aim to take humanity to the Moon and beyond, laying the groundwork for a sustainable presence on Mars. These efforts aren't just about planting flags, they're about answering profound questions. What secrets does the red planet hold? Could it have once harbored life, or might it still? Each mission brings us closer to understanding not just Mars, but the broader story of our solar system's history and evolution. But Mars is just the beginning. Beyond our planetary neighborhood, the cosmos holds mysteries that stretch the limits of our imagination. Take dark matter, for example. We've known for decades that this invisible substance makes up most of the universe's mass, yet we still don't know what it is. Future experiments like the Large Hadron Collider's upgrades or space-based observatories such as the Euclid mission are designed to detect dark matter's elusive properties. Imagine the implications. If we can uncover its nature, we might finally understand the universe's hidden architecture, the scaffolding that holds galaxies together and shapes the cosmic web. And then there's the search for life beyond Earth. While Mars is a prime target, icy moons like Europa and Enceladus are equally compelling. Beneath their frozen surfaces, vast oceans of liquid water may harbor the ingredients for life. Missions like NASA Europa Clipper and ESA's JUICE are set to explore these worlds in unprecedented detail, probing their icy shells and analyzing plumes of water vapor for signs of biological activity. The discovery of extraterrestrial life, even in microbial form, would be one of the most transformative moments in human history, a revelation that we're not alone in the universe. The tools we're developing for these missions are equally groundbreaking. Advanced propulsion systems like solar sails and ion drives could dramatically reduce travel times across the solar system. AI-powered rovers and autonomous spacecraft will allow us to explore distant worlds more efficiently, sending back data that could reshape our understanding of the cosmos. Meanwhile, next-generation telescopes like the James Webb Space Telescope and the upcoming Nancy Grace Roman Space Telescope will peer deeper into the universe than ever before, capturing images of exoplanets, distant galaxies, and even the earliest moments of cosmic history. What's truly remarkable is how these endeavors connect us to the universe on a deeper level. Every discovery, every mission adds a new piece to the puzzle of existence. They remind us that the cosmos isn't just a place to explore, it's a living, evolving story, one that we're a part of. And as we push the boundaries of what's possible, we're not just uncovering the secrets of the universe, we're redefining what it means to be human. The possibilities for discovery are endless. From probing the mysteries of dark matter to searching for life on distant moons, the future of cosmic exploration is as vast and open as the universe itself. Each mission, each breakthrough, brings us closer to understanding the celestial blueprint, not just as a map of stars and galaxies, but as a testament to the boundless creativity and wonder of existence. And in that journey, we find not just answers, but a renewed sense of awe and connection to the cosmos. The universe is calling, and the next chapter of exploration is ours to write. As we reach the end of this journey through the celestial wonders, let's take a moment to reflect on what we've uncovered. The universe, with its swirling galaxies, intricate fractal patterns, and delicate balance of forces, is far more than a random scattering of stars. It's a masterpiece, a grand work of art waiting to be decoded. From the golden spirals of galaxies to the hidden symmetries of quantum particles, every corner of the cosmos reveals a beauty and complexity that feels almost intentional. It's as if the universe itself is an artist painting with stardust, gravity, and light. Viewing the cosmos as art doesn't just deepen our appreciation for its beauty, it transforms how we understand its mysteries. When we see the universe as a living, evolving masterpiece, we begin to notice the connections between its parts, the way stars birth planets, the way galaxies collide and create new forms, the way tiny particles dance to the rhythm of quantum laws. These aren't just scientific phenomena, they're brushstrokes in a cosmic painting, each one contributing to a larger, more harmonious whole. This perspective also reminds us of our place in the grand design. We're not just observers of the universe, we're participants shaped by its processes and capable of shaping our understanding of it. Every discovery we make, every question we ask adds another layer to the story. And in that story, we find not just answers, but a profound sense of connection to each other, to the stars, and to the infinite possibilities of existence. So, as you look up at the night sky, remember this: the universe isn't just something to be studied, it's something to be experienced, to be felt, to be marveled at. Whether you're drawn to the science of black holes, the poetry of constellations, or the mystery of dark matter, there's something in the cosmos for everyone. And in that diversity of wonder, we find the true essence of its artistry. To close, let's take inspiration from the words of Carl Sagan. Somewhere, something incredible is waiting to be known. The universe is full of secrets waiting for us to uncover them. So keep looking up, keep asking questions, and most of all, keep seeing the cosmos not just as a place, but as a masterpiece, one that's still being painted, one that invites us to be part of its story. If this journey through the celestial blueprint has sparked your curiosity, let us know in the comments below what fascinates you most about the cosmos. And don't forget to subscribe for more explorations of the universe's wonders. Together, let's keep decoding the mysteries of the stars and finding beauty